All right. Okay. So morning, everyone. Welcome to the ISEE 741 3D printing class. In this semester, I will be the lecturer to teach this class. Together with two TAs. I see Cam is here, and another TA is Wenhao Yang, and both of the two TAs will assist you, will help you in the lab sessions. All right. So first of all, let me introduce myself a little bit. So my name is Yunbo Zhang, and I go by Will. I'm an assistant professor in the Department of Industrial and Systems Engineering. Also, I'm an affiliated faculty member in the School of Information, or iSchools, in Golisano. So basically, I spent 2 years as an assistant professor at Tennessee Tech University, and I was a postdoc research associate at Purdue University prior to that. You can see some nice, let me annotate. You can see some here, some nice pictures about those campuses I used to be, right? Very nice views. All right. So what I do in research is about computational tools for additive. Here are some works I worked on or I'm working on, right? So the first piece is the customized design for additive. You know, additive manufacturing is perfect fit to fabricate customized product. So how to design those customized products becomes a major bottleneck. So I developed computational tools to support the design for customized product, like the one shown here, the two, I mean the helmet, customized helmet. Basically, it will design taking the real human head as a reference, and it turns out it can be fabricated using 3D printing. Another interesting research is the 4D printing. If basically the 4D printing is a new development of 3D printing. So beyond the three-dimensional space, there is the time added onto the process. So the idea is instead of printing a 3D shape, in the 4D printing, a 2D pattern is printed, and after applying some activation mechanisms, for example, the heat or magnetic field or other energy resource, turns out this 2D shape will be folded to some 3D geometry. So that's the definition of 4D printing. So the benefit will be, well, it's easier, much easier to print something in 2D, right? You don't have to worry about support structures. You don't need to have a large space to store or to transport those 2D patterns, to pack the 2D patterns. It's much easier to do it. But on the other hand, when you want to have the 3D geometry, when you want to have a 3D product, you can easily apply the activation to let the 2D pattern self-folded to a 3D shape. So that's the beauty of 4D printing. It's an emerging research area, and here you can see I have little progress on it to fabricate some 3D shape through those 2D polymer printing, right? So the third piece of my research is the so-called generative modeling. If you ever use Fusion 360, you probably know some about generative modeling. So the idea is instead of design each of the details of the product, you just have some rough idea about what you want the product to look like, or what kind of requirement you want the product to have. And based on that, the generative modeling computational tool will generate a design for you instead of you design it. For example, like the figure shows here. Let me use a laser pointer. So if you look at this figure, that's a customized cast, right? So the traditional cast is a full cover of your arm. Instead of doing this, how about we have some hollowed patterns for those areas does not need protection. The benefit is obvious. You have lighter weight, right? And it saves material, make it more sustainable. On the other hand, it's more comfortable. You have a lightweight cast to wear, and it can breathe, right? You don't. The ventilation is much better. But the idea is how you can design such kind of product based on the requirement of the force protection. Basically, you still want these kind of products protect you. It should bear of some forces. Basically, the generative optimization framework I developed can take the requirement for the force bearing and generate those hollowed pattern for you. So that's the idea of generative modeling. And as you can see here, shows some examples coming from my algorithm. All right. So the last piece of the research is the multi-axis additive manufacturing. So for the traditional additive, basically you are printing in one direction. Once you decide what is the printing orientation, there's no way to change it, right? But that brings problems. For example, the support material. Some geometry, they have a facet facing downward, and that's not desirable because you have to print some support to support those regions. So how about we could rotate or have different printing direction during the process? That will make some regions does not require support. And on the other hand, for the material property, mechanical property of the part, if you have multiple axes, multiple direction to print, that will have some enhancement. So another benefit would be, it is possible to embed the functional parts into the printed product during the printing process. As you can see here, in this example, this model has some electronics part inserted during the printing process. And after completing the printing, you have a fully functional product instead of still requiring assemblies and so on and so forth. Also, you can even print layers instead of a planar layer, but a curved layer. So all those possibilities could bring benefit to additive manufacturing. And that's another direction I'm looking at. Actually, I'm teaming up with Professor Dennis Cormier on some multi-axis additive print process for those structural printing, meaning you have some engineering structural shapes inside the 3D object, such that you have a much better mechanical property. So these are some research area I'm looking at. So any questions? No? Okay, good. Now, there are some other research which may not be directly related to 3D printing, but more, but still centered by the human, right? As you can see here, I'm working on the augmented reality. So basically, if you ever heard about augmented reality, that's a new technology which could have the virtual content displayed in the real environment, such that you have a reference or context of the real environment when you do some design or training or some exploration of your idea. So basically, I'm thinking of how about we utilize augmented reality for design and manufacturing. And another project I'm working on related to augmented reality or virtual reality is preparing the workforce, doing the training using these kind of technology, right? And again, the human-centered design, as you can see here, this is a wetsuit system I developed a few years ago. Basically, that could help the designer to produce customized wetsuit. And it will customize to fit an individual's human shape, body shape. Basically, the challenge would be how you produce those 2D pieces, which can be fabricated in 3D, still fit the customer's body shape. All right, that's the customized design. And again, the functionality embedding during the 3D printing process, as you can see here. Here, this printer, in this printer, a fully functional mouse is printed. And during the printing process, all the functional parts has been integrated into this mouse. So it has the direct out of 3D printing functionality, meaning once the 3D printing is completed, you can take it out and use it directly without the actual assembly and handling. So that's pretty much the research I'm working on or I did previously in my group related to 3D printing. Now that's your turn. Basically, you want to introduce yourself, which department you are from, what kind of, in which year of the study you are, and some of your backgrounds, your research interest. If you are doing research, it's optional, right? If you are not, that's totally fine. Also, tell us about the reason why you take these courses and what you have known about 3D printing. What's your expectation and anything else? All right, let's do this intro. Okay, so who will be the first? Oh, by the way, I forgot to introduce my TA, Cami here. Cami, you want to say hello to everybody?
Yes, of course. So, hello everyone. I am Maria Camila, but you can call me Cami if you like it. I will be your TA with Wayne Howe. I don't know if Wayne Howe is here. I don't think so, but it's okay. We are going to meet this week. We're going to have the introduction of the different places, the 3D printing lab, the Input Center, also the workshop next to the 3D printing lab. And the next week we are gonna start with the lab sessions. So I was the TA for 3D printing last semester, and I enjoy a lot doing doing the lab sessions with you guys. So I hope everyone enjoy it as well. My research interest is 3D bioprinting, but I also like 3D printing as well. So it's a good combinations to know different 3D printers and different materials, and also different biomaterials that you can use to 3D print tissues and organs for regenerative medicine. So that's my interest. I am a PhD student. This is my second semester. And yeah, welcome everyone. And I'm here to help you and like also to learn together.
Thank you, Cami. Yeah, and so Cami and another TA Wenhao who's not here now, they will help you in all the lab sessions of this class, as well as your project. So there is a course project, basically that will requires you to design and fabricate a functional product, meaning it has mechanisms, it can do something. So in last year, we basically asked the student to design a ball pen, and that ball pen need to be working. And every team did really nice job. And the semester before last semester, I asked students to design a RC car, remote control car. But unfortunately, at that time, the lab was not allowed to be accessed. So they just designed their product without fabricated. So I'm thinking of we can do the RC car this semester as well. It's fun. I will provide all the functional parts to you, and you focus on the design and make it work in your own customized designed cars. And turns out we will have a little race, right, to testify whether your car would be functioning, whose car runs fast, right? That will be very interesting, very fun. So that's pretty much the initial plan, and I'm open to keep you guys in the loop to decide what kind of topics. But right now, I'm thinking of we do the RC car this semester, but we can talk about it later. All right. So yeah, the self-introduction. Who want to be the first?
I can go first.
Okay, go ahead, Jonathan.
Can you just throw the questions back up? Because I didn't memorize all of them.
Oh,
The
yeah,
slide that you
sure. I can copy it to the question, I mean, to the chat box.
Yeah,
so
that'd be good.
everybody can see it. Just 1 second. Yeah, you don't have to follow them one by one. Basically, you just choose the one you want to answer, you want to share with us. All right.
Okay. Yeah, sounds good. All right. So my name's Jonathan. I like to go by John. I'm in the ISC department, going for my BS and MS. So I'm in my 5th year currently. My background has always been in IE, but I'm trying to take a minor in German as well. And for research, I picked up my topic. I'm going to do long short-term memory, which is like a neural network for energy data on campus, and see if there's any forecasting method there to look for improvements in that type of thing. And then in terms of taking this course, I have had a little bit of 3D printing experience, and I really enjoyed it, and I wanted to get more hands-on with it. I just haven't had the chance to up until now. So I'm glad to be here and learn a little bit more about how the 3D printing process works.
Nice. Yeah.
I can go next. Can everybody hear me?
Yeah, who's talking? Yeah.
Okay, Zachariah. Yep.
Oh,
I go by Zach.
Okay. Yeah.
So I'm from the mechanical engineering department. This is my last semester of my master's, and I've done a little bit of 3D printing in the back with the electric vehicle team. And the reason I'm taking this course is that it's a pretty important topic in the engineering world with manufacturing. So it's always good to know.
Nice. Yeah. Oh, by the way, there are there were students who took this course previously. They, after their study, they found job because of this, because the experience they had in this class. And basically the company are looking for someone who can at least operate the 3D printer, and even sometimes fix the problems, and maybe and also they could make suggestions when the company want to purchase more 3D printing, what kind of printer would be the best fit for their business, and so on and so forth. And because of that, some of the students take the advantage using their knowledge learned in this class. All right. Yeah, next.
I can go.
Oh, sure. Go ahead, Connor.
So my name's Connor Orcutt. I'm in the mechanical engineering department, so I'm doing the BSME. I've done a bunch of co-ops that I've had to do 3D printing, and I haven't really known how to like design around it or anything. So I thought I'd take this class so that way when next time I get like a full-time job, I'd actually be like knowledgeable on it.
Good.
And then I just hope to learn like a decent amount about like the tolerancing of different things too. Like they'd ask me to do different fits, and I would just kind of guess and check. So if I could get better at that, that's what I kind of hope to learn a little bit. Thanks.
Nice. Yep.
I can go
I'll
next.
go next.
Oh.
Oh wait.
Go ahead.
Okay.
Okay. Hey guys,
Yeah,
my
go
name's
ahead.
Tolu. My name is Tolu. So I'm just gonna read off like through the thing that you provided.
Yeah.
So yeah, again, my name is Tolu. In case you didn't hear it the first two times, I'm a grad student in the data science. I studied data science in the software engineering department. My background is, as you can figure, more so in like data analytics, deep learning. I studied math in college, but the reason I'm interested in 3D printing is because I read about it on the internet, and also like in college, I have a clumsy habit of dropping my phone. So one day, I walked past the math department, and we had like a 3D printing room that like no one knew about. It was like just in the cut. So I walked in, and I got a phone case printed out, and I was like, this is actually pretty neat. So last year, I was like, remember that time I printed out a phone case? Let me like see what a 3D printer costs. So I actually like bought one. It's a Creality Ender 3V2. And this summer I've been printing. I've been like trying to design on Tinkercad, and like doing I use like slicing software. So I'm like, all right, next step, just like take a class, see how fun this gets. And I have a friend, he actually went to Notre Dame. He built a 3D printer. We're like trying to organize a small little like business, something like that. So I think that this class is like the obvious next step.
Yeah.
So yeah, that's why I want to take this course. What I know about 3D printing. I went to a store in Brooklyn, actually. I'm from New York City. So I went to a store in Brooklyn, and I saw like printers of all different sizes. I saw like people printed out axes, toy guns, and like it was my brain supernova. It was like the most, it was the coolest. So I was like, between me doing digital work, like as a data scientist, I want to have something tangible as well. So I was like, 3D printing is up. So what I hope to learn from this course, as much as I can. I know there's different methods of 3D printing. I know there's like resin. I know there's like fusion deposition modeling. Like I want to get really technical. I want to see how I can like maybe turn this from like technical, playful knowledge to maybe something commercial or even something fun. Like I have so many ideas. Like I play video games. I'm like, I could print out some characters or something like that, maybe paint it over. It could be pretty fun. And then what I want people to know from me, I'm super excited to join this course. I mean, I came to RIT in the pandemic, obviously, because I want to meet people. I want to add you guys on LinkedIn. Hopefully we'll get to talk, collaborate in some cool projects. Starting a data science club, so I recommend you guys join it. I think that there's a lot of like beautiful room for collaboration. So I think that above all else, no matter what happens in the course, I would just like to meet everyone, hopefully make some new friends, lifelong friends, and let's just like print. Let's do some fun stuff.
All right. Nice. Thank you, Tolu. And I liked your idea about from the virtual to the reality. That's basically what we are looking at, and that's the I would say the best part of 3D printing, right? Good. I think Jacob, right?
Yeah. So hi everybody. I'm Jacob Gutworth. I'm in my last semester of a mechanical engineering master's degree. And I started 3D printing doing rapid prototyping on a co-op as a sophomore, and fell in love with it. I became really interested in it. I actually also got a Creality Ender 3, and I've been kind of working on improving my 3D printing knowledge from there. I actually have a resin printer behind me now.
Oh, nice.
But I'm really interested in taking this course because I've had multiple internships with GE Aviation, and they use a lot of additive manufacturing. And I'm
Good.
hoping that I can turn my kind of hobbyist knowledge into a career with them.
Good.
Because
nice,
I'm really
nice.
interested in additive manufacturing and think that it's probably something that's going to be used for most manufacturing moving
Yeah.
forward in the future.
Yeah, it is the future. It is the reality right now. More and more industrial companies are using 3D printing for their production, not just the prototyping. Nice. Welcome, Jacob. Okay.
Thank you.
Hello. Hello, my name is Valeria. Nice to meet you all. I'm biomedical engineer, and I am exchange student for this fall. I'm from Colombia.
Oh, nice. Welcome to US.
Thank you. I work with 3D printing because I design custom devices for different kind of surgeries, something like auxiliary devices that allow to the surgeon to position the bones in new places for bone reconstruction, or reconstruction an anatomical part. So that's my background.
Nice. So basically, you will see quite a bit applications related to bio, and the one what you just described, those customized surgery and implants. That's the big, I would say, a big market.
Yes, yes, that's true.
Good, good.
Thank you.
Yeah. All right. Our next volunteer.
I can go next.
Yeah, Tino, go ahead.
Yeah, so my name's Tino Larach. As you can see, I'm in the WISC department. I'm a 5th year student. I'm actually, the reason I'm taking this class is because I came up with an idea that I want to develop using 3D printing. Hopefully a product I can then sell in the future.
Yeah.
So I'll see where that goes. I'm from Honduras, Central America, if you don't know where that is.
Yeah.
I see we have fellow Latins in the class as well, so I'm excited to meet y'all.
Good.
And yeah, like I said, I'm in the class because I want to learn how to develop new products using 3D printing. Nice to meet everyone.
I think you were in my the material processing class, right? So basically, you learn how the subtractive manufacturing look like. Now that's the additive. I mentioned a little bit there, but you will see quite a bit of details in this class. Good.
That spiked my interest a lot whenever I first took that class with you.
Yeah, nice. All right. Yeah, I see Andrew.
Yep. I'm Andrew Cluto. I'm a grad student in the MMSI program from the College of Engineering Technology. My capstone is going to be, or is in a pediatric nebulizer. So we're going to have to do a lot of 3D printing for prototypes for testing on that. So I figured this would be a useful course. My background or history with 3D printing is I've done a little bit on co-ops, but not very much. We just basically 3D printed some little spacers, little tiny prototypes here and there.
Yeah.
So not very much. So I've really wanted to learn more.
Good, good. Welcome, Andrew.
Thank you.
I can go next too if you guys.
Yeah, go ahead, Trevor.
Hi, yeah. So my name is Trevor Becky. I'm in the ISC department, and I'm doing my BSME program. So Bachelor's of Science in Industrial Engineering and Master's of Engineering and Engineering Management. I like taking this course primarily because I've experienced working in an electric vehicle startup.
Yeah.
And that moves pretty fast, and a lot of the prototyping for not just the vehicles, but for a lot of the fixtures and manufacturing equipment was 3D printed. So it piqued my interest, and I'm looking forward to trying to apply some of that, hopefully when I get a return offer, fingers crossed. So I don't really know much about 3D printing. So I'm excited to learn more about it.
Yeah, I mean, that's what people used to do, especially for startups. Basically, they prototype everything using 3D printing. And once they prove the concept, they just go to the mass production, scale up the production, find some traditional print manufacturing process like injection molding also to really cut down the price for the real product selling to the customer. But at the very beginning, when you design something, when you have your idea, 3D printing would be the best fit to prototype.
Yeah, I was surprised by a lot of the, they did their prototyping vehicles, but a lot of the manufacturing equipment, because the manufacturing lines are starting to be built now. A lot of that was 3D printed parts. It was pretty interesting because rapid changes and stuff.
Yeah, nice.
I'll go ahead and go next. If my video will start, there we go.
Oh, there we go, Peter.
So I'm Peter Sluka. I'm in the mechanical engineering department. I'm working on my BSME currently, so both at once. Currently a 5th year. And as far as 3D printing goes, I have owned, and you probably can't see it from my view here.
Oh,
but the printer
yeah, I
back
see
there,
it.
Ender 3. Had it for about 2 years now. It's worked quite well.
Good.
I've also had 2 co-ops where I've been doing a lot of very intense 3D printing. I've been managing their 3D print labs. So a couple of Ultimakers and a very old and crappy Raise 3D that nobody should ever buy. So don't do it. It falls apart if you look at it wrong.
Okay.
But yeah, so by consequence of that, I know a lot about 3D printing, mostly using PLA and PETG as materials. I've been experimenting on my home printer with polypropylene filament, which has been
nice.
Interesting. I'm very interested in aircraft, and because it's so lightweight and has structural integrity with only one shell, it's an ideal material for that. So I've been playing with that a bit.
Yeah, I think what you said about the aircraft, the materials, and also the structural design would be very interesting to explore in this class as well. I mean, I will just introduce some of those structural design using the Fusion 360. It can produce lightweight structures for the product. I mean, that's essential for the airplane, right? I mean,
yeah, I'd love to see some generative algorithms for wing internals and stuff, because that's all. That's the best way to put in efficiency and weight reduction into a design process. There is to just have a computer do it.
Yep, sounds good. Yep, hopefully you will have some fun here, right?
I think so. Thank you.
Yep.
Hi, my name is Maura. I'm part of the mechanical engineering department. I'm doing a BSME, and it's my 4th year. I'm taking this course because when I was on co-op, a lot of people around me were using the 3D printer, but I felt behind because I did not know a lot about it or how to use it. So I am more stronger in the design portion, but I don't know how to actually get it to the 3D printer. So that's why I'm taking this course, because I have a return offer for the company for an internship next summer. So I'm heading back and I want to be prepared.
Nice. I'm pretty sure you will have such an experience because of not only we will have the theory on my slides, but also you will put your hand onto the 3D printer, design something for the 3D printer. Probably there will be messing up, right? And you will learn from these, and turns out you will be knowledgeable about it. And hopefully that will be helpful for your next co-op. All right?
Yep.
Good morning, everyone. My name is Annie. I hope you can hear me.
Yes. Yeah, we can hear you.
I'm part of the industrial systems engineering degree, and I'm pursuing a master's in also industrial systems engineering. I'm in my 5th year of study, and my background in 3D printing is very limited. We did a little bit in high school. I was one of the first classes that was able to purchase a 3D printer. So we printed like little chess pieces.
Yeah.
That I was blown away by that. It was really cool. I've never seen anything like that when I was young. And my MSD project actually is to build a large scale 3D printer.
Nice.
So from this course, I actually hope to learn if we dive into the mechanics of a 3D printer as opposed to simply just the design and like the production using a 3D printer, that would be definitely helpful to me. But if not, learning the risks of using a 3D printer, different material types, issues that you might run into using a 3D printer as opposed to subtractive manufacturing or normal manufacturing, all those would be super helpful to me. And then is very interesting to me. I do have a friend who has like 4 different 3D printers. He's got the resin printer. He's got different filaments. He's played around with metal filaments or like filaments with ingrained metal in it. And he's printed so many cool things. A big Star Wars fan, so he printed a large scale Death Star. So watching him print all of that has definitely perked my interest.
Good, good. I mean, to answer your question a little bit, so we have both, not only just the using of 3D printer, but also the mechanisms for 3D printing processes, including the fused deposition modeling, those resin-based, the stereolithography, and even some of those metal printing. And also we have a really large 3D printing in our lab. You will see it during the lab tour. And that's, I don't know how large, I mean, compared to what you designed, but that's pretty large one, a Titan 3D printer, which can produce those composite plastic-based objects. All right.
I believe freshman year, they did give us a tour through the 3D printing
lab.
Oh,
good.
I remember they printed like little cubes and they also printed like the silicone item through like the really large 3D printer. And I thought that was really cool that it's not just hard plastic anymore.
Yeah. It basically, that's the real product you could use, right? It's not just for look, right?
Exactly.
Yep. Good. Oh, I see Quinn.
Yep. Hi, my name's Quinn O'Rourke, and I'm in the mechanical engineering department. Hopefully finishing my master's degree this semester, provided I can, finish up a thesis. So my research of that is developing a flapping wing drone. So that's kind of the area that I'm doing, which is part of the reason maybe could incorporate some 3D printing into that. Could see, but also I'm just interested in expanding my skill set on 3D printing to make it more marketable and like an actual job opportunity, just to make sure whenever whatever company I end up with is doing 3D printing, I want to be one of the people that they're going to including in that stuff, because I feel like those people are always involved in the more interesting, a little more cutting edge, a little more R&D, a little more kind of more fun stuff. So
nice. Yeah, I think the flapping wing is interesting, and you could utilize some of the knowledge learned from this course. For example, the structural design to reduce the weight, and also the material, right? You want to put some different material instead of those brittle rigid one, in the connection area of the wings. I'm not sure, but I'm assuming that will be part of your thoughts.
Yeah, if we ever get into flexure joints, for sure, that would be helpful.
Nice. Yep. All right.
Hi, everyone. My name is Simone Francis. I'm in the mechanical engineering department. I'm also in the BSME program, and this is my 5th year. I've always been really interested in 3D printing, but haven't really gotten into it that much. So I thought this class would be a great place to start. And also my senior design project is a large scale 3D printer, which I think someone else said, so we might be on the same team. And due to a scheduling conflict, I might have to take this class next semester instead, but either way, I'm very interested in taking this class.
Nice. Welcome. Yep. Okay,
Hey.
Victoria. Yep.
So my name is Victoria. I'm in my 4th year. I'm doing the BSME for mechanical engineering. As far as 3D printing experience, like I've used it in the past, but I don't really have a lot of experience in like different settings and like why you do just like different materials. So I'd really like to learn more about that.
Okay. Yeah, welcome.
I'll start it. Hi, my name is Mafaz. I'm in the ISE department. I'm currently doing a bachelor's in industrial engineering. A little bit why do you want things, guys? I saw a huge potential in like the job market for industrial engineering. I was
Definitely.
in 3D printing, and I thought that it would be a good skill to have in order to like search for a job. What I hope to learn from this course is just like how I just want to learn from it. I don't have that much experience in 3D printing, but I do hope to learn a lot from it.
All right. Yeah,
Yeah.
I will take care of it. Basically, it's first you get some intro and then deep dive into those more in-depth knowledge. Yeah.
Thank you.
Hey, I'm Dan Shaw. So I'm a 5th year in the industrial engineering department as well. So I had some exposure to engineering or to 3D printing in high school.
Good.
One of my teachers got a grant to buy a few. And I'm just looking to learn kind of what the new capabilities are of the industry in terms of, what we can really do with it now.
Good. Yep.
Can I go next?
All right. Okay, Carson.
Hi there, everyone. My name is Carson Steele. I'm an ISE student, my 5th year. I do have 2 3D printers, so I'm a little bit accustomed. I've never done any major design myself. That's something I'm interested in getting into. But my real specialty is going to be in sustainable engineering. I'm interested in learning more about kind of like recycled filaments. I just hear that that's a major issue right now with 3D printing is what do we do with all the waste?
Right.
Because there's a lot that can be done to recycle plastics and glasses and biocharge.
Yeah.
And how that can turn into a building material is kind of something that interests me.
Yeah, that's very interesting angle actually, from the sustainability perspective, looking at 3D printing. Actually, I have a review paper, and I reviewed some existing work. So based on their research, they figure out, well, if you, from the design stage, if you could reduce the consumption of material, that will significantly improve the sustainability of the whole manufacturing using 3D printing. So, I mean, hopefully you will find some connection there.
Yeah, that's kind of what interests me is the duality of 3D printing is, reducing the cost and the waste, but also being able to eliminate scrap at the same time.
Yeah, nice. Yeah, welcome. Oh, another Dan.
Yep, I can go. Another Dan. I'm Dan Shank. I'm a 5th year mechanical engineering dual degree student. And I've done a bit of 3D printing before. The main thing was a few years ago I used it, became familiar with it. We did a club project for Imagine RIT where we designed and built a model roller coaster from scratch, and so most of those parts were 3D printed.
Oh,
so
really good.
So we used a lot of it for that, and then since then I've used it at a couple of my co-ops. So I'm just in the class looking to become more familiar with it and just kind of learn more about it.
Yeah. That sounds good. I mean, basically, we will have more detailed intro about the series and the mechanisms for the 3D printer. So based on that, you could have a deeper understanding of the printer you have used previously, and probably could have some idea to have improvement on the existing or develop some new stuff, right? Good. Yeah. Okay.
Hi, my name is Jackie Klein. I'm in my 5th year in the mechanical engineering department, getting my BSME. I've had most of my professional experience doing just design. So I've pretty much just been handing over what I wanted to manufacturers to actually help me with the 3D printing and everything. I've actually been working virtually at a company in Chicago. So really, I just be like, here's my design, please send it to me. So I'm taking this class to just get more of the actual, more knowledge about the actual manufacturing and as part of everything, balance myself out.
I mean, you're pointing out a very important thing in the cycle of design and manufacturing. Basically, before you design something, you have to know the capability of the manufacturing process and also the limitations, such that will reduce time and effort. Basically, we will talk about this as well in the class. Yeah, hopefully you can find something useful. Okay, good. Yeah. Oh, Justin, go ahead.
Hi, my name is Justin Bookman. I entered the material science program here at RIT as a first year, but I did my bachelor's in here in microelectronic engineering. My Dr. Scott Williams gave us a tour of the 3D printing area, and I just thought it was pretty cool. And I did have a friend who used to make like stuff for like cosplays and stuff back in high school, so it just seemed interesting, and being able to apply that to more like manufacturing, like even like bio, that's the area I'm kind of interested in, is like the bio materials kind of thing. So
yeah, I mean, that will be quite a bit content in this class related to materials, and as well as how you process those materials during the 3D printing, and hopefully you will find something relevant to
looking forward to it.
Good.
All right, my name's Matt.
Yeah.
Hello, my name is Matt Dickman. I'm a fifth year in the dual degree program for industrial and systems engineering and engineering management.
Good.
I don't really have any experience with 3D printing, so that's kind of the reason I took this class, just because I've seen it, especially on co-ops and stuff, kind of become a bigger thing, and I'd really like to at least know the basics, if not much more if possible throughout the semester. So yeah.
Good. Yeah, welcome.
Thank you.
Parker, okay.
Hello, my name is Parker. I'm in the mechanical engineering department doing the BSME, as many of you are also doing. So I'm a fifth year in that. I do a lot of 3D printing at home. Something I've been exploring is like 3D printing molds to make silicone and fiberglass parts that are with more complex geometries and stuff.
Nice.
So I only kind of have like an experiential knowledge of 3D printing, and I'm really interested in the more technical aspects of it.
Good. Yep. Welcome, Parker. Do we have everybody? I think there's still one. I think we haven't have Eric, right? Eric Ham.
All right, so my name is Eric Ham. I'm fifth year industrial and systems engineering student, taking this course to get a more practical knowledge of 3D printing from a professor, rather just, I've taught myself a few things, been 3D printing for a few years now, and got it.
Hello? Yeah, I think there's a little connection problem, but I think pretty much we have everybody introduce themselves. And again, welcome to this class. And I see quite a bit your expectation from this perspective. And I will try my best to accommodate your needs, your interest, all right? And so I think it's time for a break. Let's have a 6 minutes break and come back at 10 a.m. All right? All right, let's come back for the class. So if you ever check the my courses, you should find out those informations on my courses. And also I uploaded the syllabus for this class, and hopefully you can find more information here. So basically the lecture is on Monday, 9:05 to 11. And the labs will be Wednesday, Friday, Wednesday 9:05 to 11, and 1:25 p.m. to 3:20. On Friday, it is from 9:05 to 11 again. So there is office hour on Friday, 1 to 2 p.m. Basically, you can check this Zoom link. I will be waiting there. You can just any questions, any problems you want to discuss with me, just join the meeting through this link. Basically, that's the same link of the class. All right. Any questions? No. Okay. Basically, this class is not only just lectures, but also labs. That gives you the chance to practice what you learn from the lectures. And that will essentially help you to memorize, to master the knowledge, the theories you learn from the lectures. So the objective of this class is something like this. By the end of this course, you should be able to prepare the CAD file for the additive manufacturing process, and also the operational principles for different additive manufacturing technologies, and the working principles and mechanisms for the major manufacturing, additive manufacturing processes. And you should be able to apply what you learned from the experiment, essentially the lab, to design the parts and assemblies such that would be helpful and useful to prototype the product you want to design. And the material size and also the feature clearance would be another thing you want to bear in mind through the lectures and also the lab sessions. All right. Any question? Okay. So another thing I want to point out is for modeling the parts, the geometry, we have the Autodesk Fusion 360. And RIT students has access to Fusion 360. The good thing for this CAD software is it is cross-platform, means, well, you could install it on either Windows computers or Mac. I mean, that's really good. I know the SolidWorks only allows the installation on Windows machine, but this Fusion 360 could be installed on various of different platforms. And their interface is, I would say, more modern-like, which is another benefit compared to SolidWorks. So I will post a setup file that could help you to download and install Fusion 360 on your own computer. For those who haven't installed the Fusion, that will be very helpful. All right. So for the course material, again, there's no textbook. Basically, I will provide the lecture notes and also some of the lab notes. I think lab notes would be provided by the TAs, right? And I think those materials are self-contained, so you don't need necessary to use any textbook. And for the 3D printers, basically you have the freedom to prototype what is required for the lab session, as well as some of the designs for your, the designs for your course project. And I think besides this color printer, J750 color printer, you should be able to use all the rest in the lab, in the 3D printing lab. This color printing is very expensive, and that would require some approval, not just by me, but also by Dr. Cormier, who's the director of M-Print Center, where the printer is located there. All right. Any question? No. So for the grading, you can also find this information on the syllabus, but I would like to emphasize here. So there are homework quizzes, which takes 20%, and 3 exams takes another 60%. The course project will take the rest 20%. One thing, if you ever taken my courses, you should know I never do the curve, right? So basically, you got, if your grade, your scores falls into A, I will give you A. If it's a B, I will give a B. So there's no curve. That's the good thing. I would say, based on my experience, most of the students in my past class, they all did really good job for in terms of grading. As long as you follow the lectures, you do all the required actions like submitting homeworks, participating the exams, complete your course project, contributing to it, you should be fine. You should have a good score or good grade. All right. So let's start the intro of 3D printing. Basically, 3D printing is a layman name of additive manufacturing. Additive manufacturing is the official industrial standard term defined by ASTM F2792. Basically, that describes, sorry, this term describes a series of technologies. And the basic form for this technology is to join the material to make object from 3D data. Usually it's layer by layer, but right now this layer by layer pattern has a potential to be changed. So it's not a monetary description for additive anymore. And there are quite a bit different names for additive manufacturing. For example, 3D printing, which is the most popular one. And in early age, there are other names like rapid prototyping, solid frame fabrication, which is even older compared to the rapid prototyping. But you can see the evolving of the names for additive, right? Here there shows a video for typical fuse deposition modeling 3D printer. You can see it deposits the plastic material layer by layer. So if you ever look at the history of industrial development, basically we have, so far we have experienced 3 industrial revolutions, right? And now we are in the 4th industrial revolution with some representative technologies like cyber physical systems, industrial IoTs, networks, and 3D printings. So what are the difference between the first 3 industrial revolution versus the current one? Basically, I would like to summarize the first 3 industrial revolution from the perspective of how you could make the product faster, better, and cheaper, right? Basically, you can produce zillions of products, identical ones, in very short amount of time, and such that the normal people could afford those products, which would be not possible in the historical period, right? Before this industrial revolution. But now the problem is, well, all the products are identical. You have a little flexibility to customize the product. For example, for the same production line, there's no way to produce product A and product B if they are quite different, right? There's no such a flexibility. And also for different individuals' needs, it's really hard to customize the product. So that's why we have such a fourth industrial revolution with a new communication technology, new electronics and network technology together with 3D printing, which is the new manufacturing technology. And it turns out it goes towards the more automation, more intelligence, and flexibility in the production. We would like to have those automated machines to assist a human worker to perform the production. And these algorithms, software algorithms, and hardware robots would help assist the worker to do some traditionally human task. I mean, task done by human, right? And on the other hand, the flexibility is a very important point as well here. That means you could have the customized products in terms of appearance and also the functionalities. So if we take a more detailed look at the fourth industrial revolution and 3D printing, what 3D printing plays in this new industrial revolution, it turns out it can produce the complex geometry without molds or dies or other setups. And it enables the customization. And sometimes the product produced by additive has lower cost, less material, and even better performance, right? So for example, these parts showing here, they have very complex geometry, which cannot be produced using other manufacturing process. In terms of customization, you have the teeth aligner and hearing aid buds, which are desirable to have customized design and fabrication. In terms of the lower cost, less material, and better performance, but basically these two examples shows the application for the fuse nozzle and bracket on the aircraft. And in terms of the cost and material, for example, this fuse nozzle, it achieves 25% weight reduction, and it is even 5 times stronger than the original design. The reason is this part is printed in whole instead of 27 parts and assemble them together. So which greatly improve the its performance. I will introduce this example later on, but you will see the difference for additive and the traditional printing, and the design will be different as well. And this bracket is 30% lighter compared to the original design. If you look at the back one, is the original design. All this surface is a solid surface, but now the same mechanical property is achieved. But on the other hand, there are quite a bit weight reduction. And in those aircraft applications, this is essential. It turns out it saves the material, saves the cost, saves the consumption of fuel, and turns out make this more sustainable, right? That's the benefit for additive. And in some more underlying level, the additive make, I mean, basically that changed the consumer from just waiting for the big companies' production to maker who can design and fabricate their own products. That could enable some new production models. For example, you have those desktop 3D printers, which is available for individual users, or you could have those online manufacturing processes or local production shops. Basically, you just design your parts, upload it to their server, and they will fabricate it for you and send it through those FedEx or UPS in very short amount of time. And that is only possible when you have these kind of new technology, such as additive manufacturing and also the cloud services. So we can even have more, I mean, broader impact for additive. So as I mentioned, it's really hard to customize products in the old ages. So I found this quote from Henry Ford. Basically, he said to car buyers, "You can have any color you want as long as it's black." Well, that's a really ironic statement, but the point here is, well, it's really difficult to customize car, even for the colors. Of course, now we have multiple colors, but only a finite number of choices and a finite number of functionalities. It may not be customized for, I mean, it may not satisfy your customized need, right? For the current production line-based manufacturing. So how about we have additive manufacturing? In this new paradigm of manufacturing, you can design your own product, satisfies your own need, of course, with support of the software and the computational tools. And after you complete your design, you can send it to the manufacturing system, could be a 3D printer. And turns out you have the personalized products produced and sent to you. So that's you can see the new, this new picture for additive manufacturing could benefit human beings, right? That make actually democratize this design and manufacturing. Basically, you could have, I mean, everybody has a potential to design and fabricate their own product instead of waiting for those big companies to provide their product to you, right? And that enables the possibility for those small media enterprise, right? Startup companies. And every day there's new applications for additive from this perspective of human society, right? You can see those printed organs or drugs and some apparel products like garments or necklace and so on and so forth. And here shows some footwear and also the sportwears. And even food could be 3D printed using some food printers. And if we talk about the scales, we have these printed houses, right? And even some vehicles. There are some, I don't remember where it is, but apparently there are people printing a rocket using the metal printing, which would be another very interesting add-ons to this this picture. But in short, additive manufacturing in almost every aspects of life, right? You can see there are so many applications. So basically, why we need additive? How could we utilize it? So first of all, we could use the additive to prototype what you designed before the mass production, right? For example, these pictures shows the prototyping of additive manufacturing. And you could reduce the lead time to produce those prototype. And also you could visualize the part geometry before you actually produce it for the mass production. And also, if you have something tangible in your hand, you will be easily check the design errors, find out the problems, and so on and so forth. And again, as I mentioned, for those small, medium-sized companies, you can always do the prototyping first and prove your concept before you go to a scaling up of the product, right? Another benefit for additive is you could do the engineering analysis and planning. As you can see here, these are the cars and airplanes used for the wind tunnel testing, right? I mean, of course they are they got skilled down, but it still can have the credibility for many testings, and that saves a lot of money, right? You don't need to build a real one-to-one size model to do such a testing, and at the same time, the testing result using these scaling down models would have quite rich information for you to check your design and find the problems. And in most recently, the additive manufacturing, I mean, becomes a very popular, a very favorable way to produce the part instead of just prototyping. As you can see here, for the small volume production, meaning you just print a few hundreds of or like 20, 30 pieces of the parts, you don't need the mass production. Additive manufacturing would be the best fit for it. And if you're looking at some complex geometry like the one showing here, only additive can produce them in many cases. And if you are looking at some customized product like this Invisalign teeth aligner, additive is a good fit as well for producing such a product. Any questions so far? No, let's move on. So I borrowed the concept to describe the principles of additive manufacturing, which are 10 principles. And basically these ideas are from this book. If you have an interest, you can look at it. But I don't recommend you purchase this, since additive manufacturing is a evolving area, and there are new stuffs coming out every year. This book is relatively old, but those principles are very good, and we can still use it to frame our thoughts. All right. So let's look at the first principle, that is the complexity is free, meaning no matter how complex the part is for the additive manufacturing process, there's almost no difference, right? So that's a good benefit. I will show you later more details about the cost and versus the complexity of the products for additive manufacturing and the traditional ones. The second principle is the variety is free. So as you can see here, all the parts showing here, it's produced using the same printer, using the same setup without any change, which is impossible for the production line. The production line can only produce very limited types of products, and it's hard to make adjustment if you are talking about this amount of difference for the products. So that's another benefit for additive. The third principle is no assembly required. So for some of the 3D printing process, like this chain, right? This chain is a fully functioning chain, meaning all those joints can move, which is basically that is printed in one time using 3D printing. And I assume this, I don't know that, I'm not 100% sure, but I assume this is printed using some of the selective laser sintering and a plastic powder. Basically, when you wash off the powder, you will have these movable joints. And similarly thing happens to this elephant example. And again, let's look at this few nozzle example. The old design has 20 assemblies for this nozzle, but if you look at this new design printed using 3D printer, it's a whole part printed in this one time, and that will greatly improve the performance compared to the old design, right? That's why it has 3 times stronger. It is 3 times stronger than the original design, than the old one. And similarly for this one, if you are looking at the old design using the old manufacturing process, it has 16 parts, and you have to glue them together to have this this part. But using 3D printing, there's only one part and no assembly required. It saves time as well as it improves its performance again, right? That's another benefit for additive. For the principle 4, 5, 6, and 7, they are quite similar, so I grouped them together. Basically, it is beneficial for the pre-manufacturing and the post-manufacturing, right? So basically, it make the design and manufacturing more compact by reducing the leading time and the design space, the requirement of skill level, and also it improves the compactness and the portability of manufacturing as well. So the eighth principle talk about the material waste compared to the subtractive. So if we look at an example of the CNC machine, right? So for CNC machine, it starts with a large block like the one shown here, and the material is machined to be removed from the original block. And turns out you will have the desired parts like this and a pile of scrap, right? That's the waste. And for the same parts, if you 3D print it, it turns out you are adding a layer upon layer. And of course, you want to achieve a higher level of precision that requires a little fine tuning for the printed part, but still the scrap compared to the subtractive manufacturing, it is much less, right? And if we look at some extreme case, let's see, the final part we want is something like this, right? There are large volume of empty regions. But if you're using subtractive manufacturing, you still need to remove that much materials from this solid block. And it turns out it's a 20-to-1 buy-to-fly ratio, which is really a big waste. So just imagine if we 3D print it, basically that's very little material required, right? So that's the case if we talk about there's less waste by the production using 3D printing. So another I would say benefit for 3D printing is the material, the variety of materials. So as you can see, if we look at this one, it has multiple material, multiple colors, but it is printed in the same process. And also here, it shows these rhino, and each of them has different material properties. Some regions are soft and some regions are rigid. And also these ones, right? You can see it has all different colors, if color can be considered as a material property. Some new advancement, they integrate metal wires with the plastic substrates to produce some functional parts, like the one shown here, right? So as you can see here, it has the potential to integrate different material together in the same path of process. Instead of print the parts in different assemblies, and each assembly has one material, and you need to assemble them together and make it work, right? That totally changed the process. Sorry. And the last principle or benefit for additive is it could enable the precise replication of a physical model. Basically, you want to, like the statue showing here, you just do a 3D scan, and then with a digital model, you can directly print it out like something like this. And compared to the original one, it is a very precise replication. So some of the business actually is based on this, right? Like the one showing here, this young dancer is 3D scanned, and then a statue is printed for her. So that could be some enabler of business, right? So if besides these 10 principles, let's look at some of the concepts for the thoughts of when and in what case we should use additive manufacturing instead of traditional ones. So here, this figure shows the complexity versus cost. The horizontal one shows the geometric complexity of the parts, and the vertical one shows the cost. So if we look at the traditional manufacturing, which is in blue, if the complexity increase, this cost for traditional manufacturing will increase dramatically, right? Exponentially, I would say. But for additive, it's a straight line. That means no matter how complex the part is, the only thing for additive is the volume of the part. If the volume is larger, that means it consumes more material, and that's a linear relationship. So per unit volume, the cost is all the same. So that's the, I would say, a biggest benefit for additive manufacturing. When you think of prototyping or producing some products with high complexity, right? That's the thoughts of the complexity versus cost. So when you make decision whether I should go with additive or traditional manufacturing, just think about the geometric complexity. If it is very complex, definitely go with additive. Otherwise, maybe traditional traditional manufacturing has more advantage, right? So basically, we need to be very careful about it when you decide the manufacturing process for your design. Another very interesting thought is the units per cost. Units means the units of your product. And if you look at this figure, the traditional manufacturing has a very high cost if you have very few units, right? And that is because the leading cost, lead cost, and also the cost for the toolings, and the cost for the manpower who prepare the production line, the manufacturing process, that is very high. And if you do not have an appropriate units for the products, the cost cannot justify, right? Cannot justify those. But for additive, again, it is a straight line, meaning, well, no matter the units for the product is low and or high, per unit, it costs the same. But for the conventional manufacturing, it is a curve like this. That means if you have more units produced to use conventional manufacturing, the per unit cost will drop, right? And there's a breaking point. So you need to be aware of this. So anything below this break point, you want to use additive manufacturing because it has a much lower, in most cases, much lower cost. But if you're talking about something beyond this breakpoint, that means if you really want to go with the conventional ones, and that will have a lower per unit cost if the units of the production is that high. So that is another consideration you need to take when you design your product, plan your manufacturing, right? So these two figures I want you to keep in mind, and that will be useful for you to think of the design and the manufacturing. Any questions so far? All right. But additive manufacturing or 3D printing is not perfect, right? The big number one problems for additive is the part accuracy. So as you can see here, to print this semi-sphere, there's a so-called staircase appearance. As basically that is because you are actually slicing the part into different layers and print them layer by layer. And it turns out you will have such kind of stair look surface. It can be improved if you have more layer that essentially reduce the height of each of the layer, and it turns out make the surface better. But it cannot be fully solved even by increasing the part accuracy. The layers of the printing. And another problem is the limited variety of materials for 3D printing. So one big chunk of research directions are exploring the possibilities to use more materials for 3D printing. And basically that is because there are very limited amount of material could be used for 3D printing. So if we could have more materials utilized in 3D printing, that will definitely improve the capacity of 3D printing. And a holy grail problems to be solved in 3D printing is if we could develop a layer-based process that can compete with the injection molding or metal casting on the basis of speed, cost, and part quality, then I would say we have the holy grail. But that's really challenging, right? You know, the injection molding is very good for producing the mass-produced products, and as well as the metal casting. So how could the speed and the cost to be that great? But I would say the part quality may be a good point for the 3D printing to catch up. But the most challenging part is how could you maintain the high part quality using 3D printing, but at the same time maintain the high speed and the low cost comparable with injection molding and metal casting. So if you want to achieve these three together, that will be really challenging problems. But researchers and people are looking at this and trying to make some breakthrough, right? So the basic concept of 3D printing, as I mentioned previously, that is, well, you want to add layers of material one at a time to build the solid part from bottom to up. And this is the general set concept for 3D printing. It may not be true for those emerging ones, the new ones, which may not have this kind of layer-based process, right? But here we talk about the general cases and the original cases. And there are different starting materials in 3D printing. It could be liquid, the resins, right? And it could be powders or a wire or filaments. There are some processes utilize the solid sheet. Basically, these solid sheets are laminated to create the solid part. Actually, there's a machine in our lab which is based on the lamination. I don't know whether Cami and Wenhao would introduce that to you as well, but that's the newest machine in the Brinkmann lab. All right. So based on the different materials and the working principle mechanisms, there are 7 categories of additive manufacturing processes, and there are more and more variations coming out each year. But roughly, they can still fall in these 7 different categories. And they are the material extrusion, powder bed fusion, vat, photopolymerization, material jetting, binder jetting, sheet lamination, and direct energy depositions, right? And probably we will talk about some of the process which follows, which fall to some of the categories: material extrusion, powder bed, and vat, photopolymerization, and the jettings. I'm not sure. I think we will not talk about the sheet lamination. But yeah, that's pretty much covered most of the popular categories of additive manufacturing processes. So for example, if we look at the vat polymerization, and the representative technology is this stereolithography, in short SLA, and this is invented in 1984 by Chuck Howe, who's the founder of 3D Systems, which is a key player in 3D printing market. So the idea is basically the light source, some light energy, could be laser, ultraviolet, natural light, and so on. This light energy is utilized to cure the polymer, liquid polymer. And I don't know if I could show the video, but let me have a trial. Can you see my screen? Oh, it's not available. Huh. I think I can. Oh, there's the questions. Okay, I see some talk about the rectangle. Let me try to. Oh, I think that is the scription. I mean auto scription. Let me have a file to.
Professor, it's the whole screen
if
now.
If you have another window open on top of the window you're screen sharing, it just covers up that part of the screen and we can't see it.
Oh, yeah.
You can't see whatever's in the middle of your screen right now. It's just covered by some box.
Okay. Yeah, let me a trial. Oh, yeah, because I only shared this exactly. I will try to open it on my Explorer. I mean the Chrome. Okay, let me share this. Just 1 second, let me share my screen. Can you see my screen right now? Can you see my screen right now? Okay, good.
Stereolithography is a rapid prototyping process used to create parts from 3D CAD data in a matter of hours. SLA is a highly accurate additive manufacturing process and may also be referred to as rapid prototyping or 3D printing. Models created with this technology are typically used as concept models for form and fit studies or as master patterns for molding techniques. The SLA process begins when CAD data is sliced into thin cross-sections or layers, typically about 0.006 of an inch thick. This data is then transferred to an SLA additive manufacturing system containing a vat of UV curable photopolymer. The machine begins to build the part one layer at a time. Each layer is constructed from an ultraviolet laser that is directed by X and Y scanning mirrors. As the laser traces the cross-section on the surface of the resin, the liquid material is hardened on contact. Once a layer is complete, the build platform is indexed down to make room for the next layer. A recoater blade moves across the surface, ensuring a thin coat of fresh liquid resin is evenly spread over the object. The laser continues to trace and form each layer atop the previous layer, building from the bottom up. The completed part is then carefully removed from the liquid and separated from the platform. A chemical bath removes excess resin, and the part is cured in an ultraviolet oven. Any support structures are removed at this time. With numerous hand sanding and professional paint options available through service providers such as Solid Concepts, stereolithography has become an excellent economic choice for rapid appearance models. A wide variety of industries have embraced SLA, including medical, automotive, entertainment, aerospace, and consumer products.
All right. So that's pretty much what SLA look like, and you will have the chance to play with the SLA machines. I think. Let me stop the share. I think there are some issues for PowerPoint. Just 1 second. Yep, so here. So actually, even for SLA, there are different types. There are top-down process and also the bottom-up one. So the top-down one, based on the name, it print the parts. Basically, it print the parts from the bottom portion to the top portion, right? But for the bottom up one, as you can see here, the platform is on the top and it prints the parts from the bottom to the top. As you can see here, this shows how it looks like. And the rightmost figure, I mean the GIF shows the carbon 3D printer, which is the very recent product, which can produce a part in very short amount of time. It prints a Eiffel Tower by just pull from the bottom of the tank in very short amount of time. I will introduce the details later, but just let you know there are different variations for SLA, and I will introduce the pros and the cons and why we have both of them, right? And another very popular additive manufacturing process is the material extrusion. And essentially, we have the fused deposition modeling that is invented by Scott Crump in 1980s. And he founded the Stratasys company, which is, again, a main player of 3D printing. So basically, the thermoplastic such as ABS, PLA, or nylon are utilized as the printing material. And the thermal energy is used to melt the metal material and deposit them one by one, right? As you can see here, all these objects are printed using the fused deposition modeling. And this is the by far most affordable 3D printing process as well. And it got basically it booms in 1914. I mean in 2014, because of the original patent for fused deposition modeling got expired. So those other company could have the chance to build their own machine, their own fused deposition modeling machine, and that makes this process more and more affordable and accessible to people. And I will introduce more details in the later classes as well. Another big family for additive manufacturing is the powder-based fusion, powder bed fusion, including the selective laser sintering. They are usually for the thermoplastic powder, and a direct metal laser sintering. And this is for the metal powder more. And basically, these are very interesting additive manufacturing process for industry production, like the one like the GE Aviation, right? They produce those I mean the engines, right? The aircraft engines, some of the parts using the powder-based. The 3D systems and the yields are the main players, and I will again introduce some of the details later. Material jetting, it is similar to the inkjet technology in the 2D printing, right, for our printer. And it can produce very good colorful appearance of the product. There are new developments like the Vader system, which we have. I mean, we have a machine in the Brinkmann lab, and it also a type of jetting printer. It jets the metal liquid. It turns out this is another popular research and business area for 3D printing. There are new research and the new machines coming out every year, because this is quite flexible process, which could utilize different types of materials like polymers, like plastics and metals, and so on and so forth. Binder jetting is similar to the inkjet printing, but it has a binder, means glues, right? It will the glue will bind the powder together for each of the layers. And after the whole part is printed, those binder will be removed by usually sintering. And it turns out you will have a finished part with good material property. And some famous company like Zilcop, it was acquired by 3D Systems in 2012. And X1, actually this X1 is under, I mean, there's a rumor X1 is under the acquisition by the Desktop Metal, which is a very popular startup companies recently. Yeah, we will talk about the process later in details. So as you can see here, we have very good facilities, additive manufacturing in the M-Print Center at RD, as well as the Brinkmann labs. We have 15 faculty members there, and we are focusing on the multifunctional 3D printing. So you will have the chance to have a tour in the both Brigham Lab and M-Print Center. And I think that's I think the time. Yeah, it's a perfect timing. So any questions so far, since we still have like 4 or 5 minutes? Good. All right. I hope you will enjoy the tour on Wednesday and Friday. And again, I will post this video as well as the first lecture notes to my courses. And I will be there for the office hour on Friday. So if there's no further question, that's the end of this class. Thank you for your attention.
Thank you.
Thank you, Professor.
Yeah, no problem. Yep.
Dr. San.
Yeah.
Professor, I have a question, sorry.
Sure, go ahead.
I'm enrolling the labs on Friday in labs, I think that is group 2.
Yeah.
But I'm crossed with another class that is fundamental of sustainable. I don't know if maybe it's possible that I could change it to Wednesday at 1 p.m.
Yeah.
Is possible?
I think it's possible, but you want to email Jane and CC me. You know who Jane is, right?
No, no, I don't know.
Yeah, let me just quickly type his email. Basically, she's the she's in charge of the course registration and scheduling. Let me find his.
Mm-hmm.
I
will say, Valeria,
do you have availability for Wednesday at 9:05 a.m.? Because
No,
the
because-
group,
Okay. It's the same situation. Because I have this class Monday, Wednesday and Friday, 9 to 10 to 11. So,
okay, so Dr. San, for Wednesday at 1:30 p.m. we have, with Valeria, we have 9 students. So maybe one group of 3 students, it will be fine.
Yeah, that's fine. That's fine.
Okay, okay, so that's
Yeah,
good.
yeah. Valeria,
Yeah.
basically, I just post Jane's name and email address there. So
Okay.
yeah, you just email her and the CC. We can start with that. All right.
All right. Thank you very much.
Yep, no problem. Thank you, Cami.
Yeah, you're welcome.
I have a quick question too.
Yeah, Connor.
What time is the Friday lab that you were
That's
referencing?
9:05 to 11.
Okay, 9:05 to 11. All right.
Let me double check.
Yeah, that's correct.
That's correct. Okay, good.
Yes.
Cool. And is there any way, what was that email again? In case I might have it scheduled. Oh wait, there it is in the chat. Okay, never mind.
Okay.
So sounds good. Thank you.
Yep, no problem. All right, any other questions? No? Okay, I'm gonna end this session, this Zoom session, and see you guys. Yeah, go ahead. Nope. Okay.
No question. Okay,
Yes.
bye-bye.
Bye. Bye.
Bye.